My big thing with education and with my professional career is the key is load path. And if you can understand the load path, you can get it to work. If you can make the details work, the engineering comes in later. Right? If you need a 5/16 inch weld or a 3/8 inch weld, who cares? It's just it's a number, but the detail needs to work first. And what I see with many of my students is they've never been exposed to load path. Within this profession, the structural engineering profession, a lot of it is offshored, right? A lot of it is farmed out to engineers in second and third world countries who are just as smart as us, but their standard of living is so much lower that they might be getting $15 an hour. I can't compete with that. I'm not doing this for 30 years to make $15 an hour. So I can get anybody to do the numbers. I can get anybody to run the analysis model. That's the easy part. The analysis model will tell you how much the beam deflects, how much the building sways under a lateral event. What it won't tell you is, do you have enough columns in there? Is this span too long? Is this even a reasonable solution? So that's what I take to the coursework at RPI.
How take me through the students over the course of a semester? So they get kind of plopped into this new experience. Do they freak out? Do they worry? How do the students deal with this new information in your class?
The students that go on to become PhDs do not like the course. They're used to doing 20 pages of calculations every night. And I've actually had some of them say to me, I was expecting more homework for a graduate level course.
Okay.
The ones that want to be practicing engineers will say, this is the best course ever, because everything up to that point, whether it be a steel course, a foundation course, a concrete course, it's all element based. Size of beam, size of column, size of footing. When they graduate, they're expected to design a building, not just the beams and the columns. The capstone, sure, that does take it all together, but the capstone, again, is run by professors who actually designed a building. And I'm not saying anything negative about them, it's just they have their thing, and I have my thing. And most of the students that come out want to be practicing engineers. And so some of them panic. It's like, I've never thought of this. What's the formula for the number of columns in a building? It's like, well, X is greater than or equal to 1. You need at least 1 in the building.
Sure.
And I say to some of them, look, you know how to do this. You have, as structural engineers, we have an understanding of load path, even if we don't realize it. I say to them, why do you think a tree is fat at the bottom and skinny at the top? There's more load at the bottom. Axial load, lateral load, bending forces. It's at the bottom, not at the top. That's why the tree is bigger at the bottom. We all know that when we're on a boat and it starts to wobble, what do? We put our hands out to balance ourselves. That's all basic load path stuff that we're born with, if you will. We just never think of it that way.
And I'm empathizing because from family of contractors, I wasn't naturally inclined to go into engineering. It was kind of a family pull. No, but RPI, I'll do undeclared engineering, I'll do civil engineering, I'll do structural engineering. Mm-hmm. It was the closest thing to architecture, and I thought it'd be cool. But I was a little disenfranchised with the gig because I'm doing nothing but monkey tricks. These equations can run, Excel can do these equations. Why do you need me? And I lucked out with an advisor who had steel design class that was basically like I said this earlier today, the midterm and the final were oral exams.
Mm-hmm.
So I'm going to sit with you in for an hour and ask these same 6 questions, and if I think you know what you're talking about, I'll give you an A. If you're fumbling a bit, B, and if it's a disaster, C. And that made you think of it in a new way, and it was wonderful.
Yeah.
And share this one other comment. The way that, and this was unique in my education career, it was the one person that kind of turned this around for me. It opened up a world. His senior level steel design class, the first homework assignment would be basically design this one building.
Mm-hmm.
The geometry was sort of formed, but I want to see details for all these different connections. And there would be panic at the disco, right? We never learned this. Who are you to blah, blah, blah? This is impossible. No. And people would submit the garbage, and everybody would get their 20, and there'd be panic. But it's like we're doing this at the beginning, so for the next 14 weeks, we can keep working in the same problem. So by the end, you solve this, because if I build up to this point at the end, you're not going to know what you're doing, and you're going to go off.
Yeah, yeah.
So I'm just sharing that.
Mm-hmm.
Sounds like I think your approach is the right one.
Okay, appreciate that. Thank you. So we use that. We develop a column grid, and we use that for the rest of the course. Okay. Now that we have a column grid, we're going to size some beams, and then we're going to size. We're going to look at lateral loads. We're going to look at. We're going to check the floor for people-induced vibrations. We're going to look at edge connections and torsion. We're going to do this, and we're going to do all of that based upon what we did the first week, because that's the way that I operate in my professional career. As an engineer who develops plans and specifications for buildings, that's what I do. I take the floor plans that the architects generate, and I start putting it to reality. So, generally speaking, it's been very well received, at least based upon the reviews that I get every year, which are very, very high. But there are always some who will say, what formula do I use for this? And we've never learned this. And it's like, guess what? I teach a masonry course. I didn't take any courses in college on masonry. You know how I learned it? I learned it. Most of the calculations that we do in the steel course, when I took the course over, I hadn't done that in 25 years.
Right.
Like, I got to learn how to do a composite beam design again. Okay. Well, I learned it.